Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about star delta transformation. Okay, so what is star delta transformation? It is basically a technique. That is used to simplify three-phase electrical circuits. Okay, and in this technique, we convert a three-phase star connected system into a delta connected system, or you can say vice versa. Okay. So let's discuss our first case, which is your delta to star conversion or delta to star transformation. Okay. So as you can see, the equivalent resistance across these two terminals A and B. So the equivalent resistance RAB will be equal to the series combination of RB plus RC in parallel with your RA resistance. So we can say that RAB will be equal to RB plus RC in parallel with RA. Okay. So on solving it further, we are getting RARB plus RARC over RA plus RB plus RC. Okay. Also, in the given figure, we can also see that the value of the RAB will also be equal to R1 plus R2 when R3 resistor is your in open circuit condition. Okay, so it means that RAB will also be equal to R1 plus R2. Okay, so equating these two equations, we can see that R1 plus R2 is equal to RA RB plus RARC upon RA plus RB plus RC. Okay, so let's say this is your first equation. Similarly, we can see that the equivalent resistance across A and C terminals, which is your RAC, will be the series combination of RA plus RB in parallel with your RC. So we can see that RAC will also be equal to RA plus RB in parallel with RC. So that is coming out to be RARC plus RBRC upon RA plus RB plus RC. We can also see that the value of the RAC in case of a star connected network will be R1 plus R3. It means that RAC will be equal to R1 plus R3. It means that R1 plus R3 will be equal to RARC plus RBRC upon RA plus RB plus RC. Okay. So this is your second equation. Okay. So similarly, we can see that RBC will be equal to RBRC plus RARB upon RA plus RB plus RC equal to R2 plus R3. Okay. So this is your third equation. Okay. Adding first and second equation and subtracting it by the third equation, we can see that 2 times of R1 will be equal to RARC, 2 times of RARC upon RA plus RB plus RC. Okay, so it means that the value of R1 will be equal to RARC upon RA plus RB plus RC. Okay, so this will be the value of the R1 when we will convert a delta system into a star system. Okay, so similarly R2 will be equal to RARB upon RA plus RB plus RC. Okay, similarly R3 will be equal to RB RC upon RA plus RB plus RC. Okay. So I hope it is clear how we are able to find the value of R1, R2 and R3. Okay. Let's say if the value of RA is equal to RB is equal to RC is equal to R. Let's say all the resistors have same value. It means that this implies the value of R1, okay, R1 equal to R2 equal to R3 will be equal to R upon 3. So it means that the value of the resistance decreases by its 1/3 value when we convert our delta system into a star system. Okay, so I hope it is clear. Okay, let's discuss the second case, which is your star to delta transformation or star to delta conversion. Okay, so we know that the value of R1 is equal to, from delta to star transformation, will be equal to RA RC upon RA plus RB plus RC. Okay, let's say the value of this denominator, which is RA plus RB plus RC, is equal to delta. Okay, so we can say that R1 is equal to RA RC upon delta. Okay, similarly the value of R2 will also be equal to RA RB upon delta, and RC will be equal to, and R3 will be equal to RB RC upon delta. Okay, so it means that the value of R1 R2 plus R2 R3 plus R3 R1 will be equal to, so RA RC upon delta into RA RB upon delta plus RA RB upon delta into RB RC upon delta plus RB RC upon delta RA RC upon delta. Okay, so it means that, so we can say that on simplifying this equation, so RA square RB RC plus RB square RA RC plus RC square RA RB upon delta square. Okay, so it means that which will be equal to, so on taking RA RB RC common, we can say that RA RB RC upon RA plus RB plus RC upon delta square. So the value of this RA plus RB plus RC is already equal to delta. Okay, so it means that delta will be cancelled out by delta. Okay, and now it means that we are getting the value of R1 R2 plus R2 R3 plus R3 R1 is equal to RA plus RA RB RC upon delta. Okay, so it means that, so we already know the value of RB RC upon delta is equal to R3. So it means that the value of RB RC upon delta will be equal to R3. So it means that RA will be equal to R1 R2 plus R2 R3 plus R3 R1 upon R3. Okay, so I hope it is clear how we are getting this expression. Okay, so this will be the value of RA when we convert a star system into a delta system. Okay, so similarly we can see that the value of RB will be equal to R1 R2 plus R2 R3 plus R3 R1 upon R1. Okay, similarly RC will be equal to R1 R2 plus R2 R3 plus R3 R1 upon R2. Okay, so let's say at a special case, okay, the value of R1 equal to R2 is equal to R3, all the resistors are equal, and let's say they have a value of R. So it means that the value of RA equal to RB equal to RC will be equal to 3R. So it means that if all the resistances of a star system are equal, so it means that the value of the resistance increases by 3 times when we convert a star system into a delta system. Okay, so from this particular tutorial we can easily see that when we convert a star system into a delta system, the value of the resistance increases. Okay, on the other hand, if a delta system is converted into its star version, okay, then the value of the resistance decreases. Okay, so the value of the resistance decreases. Okay, so that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.